In this video, we are going to solve these two numerical problems from chemical kinetics. But first we have to know the theory. Suppose we have a reactant R. This reactant R produces a product P. One mole of the reactant produces 1 mole of the product. Now as the reaction proceeds, the concentration of the reactant decreases, whereas that of the product increases. Suppose at time t1, the concentration of the reactant R is R1 and that of the product is P1. And let at time t2, the concentration of the reactant be R2 and that of the product be P2. So what is the change in time? T2 minus T1. Change in the concentration of the reactant R2 minus R1. And change in the concentration of the product P2 minus P1. Okay, the square bracket means the concentration. Okay, now we come to the rate. First, rate of disappearance of a reactant R. This is equal to decrease in concentration of the reactant R divided by the time taken, and this is equal to minus delta R by delta T. What is the meaning of this negative sign? See here, we know that as the reaction proceeds, the concentration of the reactant decreases. So this would be a negative quantity. So in order to make the rate of disappearance of a reactant R positive, we have to multiply by -1. That's it. And then now rate of appearance of a product P, this is equal to increase in concentration of the product P divided by the time taken. We know that the concentration of P increases as the reaction proceeds, so here we have the positive sign. Delta P, change in the concentration of the product by delta T. Okay, here you can write this one as R2 minus R1 divided by T2 minus T1, here with a negative sign. And here we have concentration of the product at time T2 minus concentration of the product at time T1 divided by T2 minus T1. Equation 2, equation 1. Equation 1 and equation 2 represent the average rate of a chemical reaction. Okay. Okay, based on these, let us try to solve these two numerical problems. The first one, see here, 1 mole of the reactant produces 1 mole of the product. Now we see that the concentration of the reactant changes from 0.03 molar to 0.02 molar in 25 minutes. there is a decrease in the concentration of the reactant as the reaction proceeds. We have to calculate the average rate of the reaction using units of time both in minutes and seconds. Okay, let us do this one. Solution. What is T1? 0 minute. And then time T2, it is 25 minutes. Concentration of the reactant R at time T1 is equal to 0.03 molar. And that at time T2 is equal to 0.02 molar. Now, average rate of the chemical reaction is equal to minus change in the concentration of the reactant by change in time. Okay, minus this one is R2 minus R1 divided by T2 minus T1. 0.02 minus 0.03 by 25 minus 0. And from here we have minus 0.01 by 25. So this is a positive quantity. When 0.01 is divided by 25, we get 4 into 10 to the power minus 4, and the unit is molar minute inverse. Now see, the question wants us to find both in minutes and seconds. So now we convert minute into seconds. We know that 60 seconds make 1 minute. So from here we have 4 into 10 to the power minus 4 molar by minute. 4 into 10 to the power minus 4. See here, in place of 1 minute I have 60 seconds. Then 4 into 10 to the power minus 4 by 60, and then molar second inverse. Okay, so we get the final answer to be 6.67 into 10 to the power minus 6 molar second inverse. Hence we have found the rate of the reaction using units of time both in minutes and seconds. Let us do the second problem. See here, 2 moles of the reactant gives you a product. Okay, and it is seen that the concentration of this reactant A decreases from 0.5 mole liter inverse to 0.4 mole liter inverse in 10 minutes. That means there is a decrease in the concentration as the reaction proceeds. We have to calculate the rate during this interval. Solution. T1 is 0 minute. T2 is 10 minutes. Concentration of the reactant A at time T1 is equal to 0.5 mole liter inverse, and concentration of the reactant A at time T2 is equal to 0.4 mole liter inverse. Now, what is the rate of the chemical reaction? Okay, minus change in the concentration of the reactant A by change in time. Okay, but here you have to be careful. See here, we have 2. Okay, that's why you have to multiply by half. Okay, minus half. This one is concentration of A at time T2 minus concentration of A at time T1. Then divide by T2 minus T1. Substitute the value. Here we have 0.4 minus 0.5 by 10 minus 0. So we have minus half into minus 0.1 by 10. And this one is equal to 0.1 by 20 Finally, the answer is 0.05 mole liter inverse minute inverse, or this one can be written as 5 into 10 to the power minus 3, and then here we have molar minute inverse. So this is the rate of the chemical reaction.